not going to use that piece of it here. So welcome. My name is Brian Fowler. I'm the Director of Operations for ESC Spectrum. Basically, I've been involved in SEMS, monitoring, DAS reporting for about the last 15 years. I've played a lot of different roles within ESC and now ESC Spectrum over the years, everything from an implementation engineer to project manager to sales support to covering marketing activities to now all of the operations for our software division. So I'm here because we had some questions about DAS, and I've given a presentation like this over the years, the last couple times, or since 4C started here in Austin, and we started participating in it. And I first came out, I was very partial to three-letter acronyms. So I'm going to go ahead and tell you right now, I've accepted the fact that, okay, DAS, while it has a silent H, I don't like to spell it all out and have it linger that way. The H is actually a big part of what a DAS provides. It's that handling piece. So it's the data acquisition and handling systems, right? So that's really what it was all about. And I gave a presentation at first, like I said, when first started with this, and I said, no, I just like the word DAS. DAS is simple, it's 3 letters, it's way to go. So I have acknowledged now the fact that the advantage really is in the handling part, because there are many different platforms to be able to collect data, right? There are a lot of different data collection devices. If you think about it, our phones from the smart meters on the side of our house collect data, right? Data is being collected all the time, and data is powerful, don't get me wrong, but there are things that from an environmental standpoint that have to be done to it in order to show compliance and demonstrate and follow all the guidelines and the rules. So the handling is a big part of it. So I'm going to try to highlight some of the differences in what a DAS does versus an EMIS versus a historian. And I'm not trying to knock any one of those platforms. It's just that they're designed for different purposes, right? They were designed to do different things. And so we'll talk a little bit about that. And one of the reasons, the differences that the DAS brings over an EMIS or some other data collection platform. So with that, if you look at it, you have the discrete records. And so here's some of the highlights, and we'll go into more detail and show some examples. But the discrete record retention and storing those data points, right? There's complexities in some of the calculations, as you saw in previous presentations this morning with PS9 calculations and some of those types of things. And it's not just Excel math all the time. EPA doesn't always follow the same rules. And so you got to be very specific about how that's done. And then you've got the transparencies. We've talked about more about, the looking at the data and understanding the data integrity and its life from start to finish, analyzer to report. Where is that coming from, right? So, and then also the DAS can play some key roles into integrating the various systems and pieces of the system, and we'll talk in more detail about that. But if you think about it, it's integrating from analyzers, it's integrating from DCS. You're pulling information from a lot of different places around the facility, so it's important to have like a hub to kind of pull all that together. So let's go into some of the data records and retention. Oh, I forgot about this little part right here. But so we had a meeting yesterday with all four. We'll touch on that, and EMISs and the challenges with implementing EMISs and getting the data. EMISs are really designed to enter this 1 minute and 15-minute level data on such a large scale, right? An EMIS is taken in data from fleet-wide or corporate-wide. There's a lot of information in there, not just the SIMS-related stuff. And so it just doesn't have quite the room or the logic to be able to handle that and apply that information. So that's one of the things with the EMIS pieces, and when talking and working with all four and learning more about implementing those, they should be integrated. They should be working together and sharing data. And that's one of the bigger challenges there. The historian, as we talked about, in many cases, by default, historians are set to compress the data over time, right? They do that for space saving and things. And so you may not have the discrete level 1 minute and 15-minute values that you need for the reporting purposes. So, they're there for process trends and looking at supporting that sort of options. They just don't. And they also don't have the logic behind doing the natively the calculations and the complexities around the compliance rules. So just as in some examples, and we borrowed this from other presentations before, but these are some of the examples of the data pieces that are required when you start looking at that, and then the data retention. So you're keeping 15-minute averages for 5 years. That's a lot of information, and it adds up pretty quickly. So here are all the various points in terms of how long you need to keep them in the intervals that state. And if you're reporting a 15-minute data period, don't you want the values that feed into that 15 minutes so you can show the compliances and how you came up with those intervals? I would want that. I'd want to be able to stand behind, this is how I came up with this 15-minute value. So you then have to keep the minute numbers, the minute values, to be able to support how you calculated that 15-minute average. So again, the data and retention records is a key part of this, and there's a lot of information here. And this is just, for one source. Then you multiply that by all the different sources at the facility affected. It adds up really quick in terms of what you're trying to do. And again, do you really want to flood the historian and other pieces of information with that, or do they just need to find final compliance averages and that so on and so forth? So this is a quick example of a data point, right? So we have hourly values being collected for NOx, and we have indicators on the flags because it's not just about a number. There's some status indicators that we need to capture as well, because capturing this value, you need to know what happened in that period of time, what activities were performed, other things along those lines. Do I have enough data to make a valid data point, right? And there's rules around that, as we talked a little bit this morning about the number of data points that are needed to complete a solid 1 hour average. So in this case here, that hour 6, we've got an indication of, we've got valid data. There was some activity going on during that hour, calibrations. So let's drill into it a little bit. So if you look at it, now we've got the 15-minute periods of which that build up that 1 hour. And again, we see that there was this one block where in that 15-minute period, you have some activities and flags. There was a calibration or a validation run during that 15-minute period. Well, therefore, it's marked that period invalid. I still have the other quadrants to use to build the hourly average, right? So when we dig into this further, you've got, now you see, okay, let's look at the minute level values. So again, here are the minute level values that went into that first quadrant. And I can see each minute had some calibration activity going on. And so I pulled those numbers out because again, I've got to have the good versus the bad data that I'm using. So I've marked all this data as invalid and so therefore not be used. But you've got the data behind why you said you couldn't use that 15-minute period when you were submitting your averages. So you really need, in my mind, be able to stand behind and have the detail behind the data. So this is just a quick example. In a glance now, I can see the parts and pieces that build up to that 1 hour average or that 15-minute interval that I have to report or not able to report because I don't have enough valid data to support it. So, and this is where DAS excels. DAS can understand these pieces and rolls these data values forward. You don't have this granularity traditionally in a historian or in an EMIS system, especially not for 5 years. I mean, that would be huge in terms of the size, in addition to everything else those systems are recording and tracking at this point. So that, to me, this is one of the bigger ones. So all of this is in support of that 1 hour value that you have to submit for different compliance reasons. So, and then we get into some of the hourly calculations and the interpretations of how that works, right? So depending on what school of thought you work, does the hourly value roll up arithmetically for minutes, or does it use the quadrant math? Well, I mean, there's not really a wrong way. You just need to understand what your permits and the different programs require you to do. So you have to be able to, in some cases, maybe use both. And in Eric's last presentation, maybe opportunities to harmonize your permits so that you don't have to do it both ways. Because this old permit says I do it this way, the new rule says I have to do it this way. Now, this is an example of being able to harmonize that. But in some cases, you don't have a choice, and you need to be able to have, the different calculation methods done and displayed in the DAS itself. Again, this is not something natively that those other platforms can handle because, again, they're not designed for that. And then it comes into, just give me a 3 hour average. Well, there's a lot that goes into a 3 hour average, right? You have to understand, well, how many hours do I need in that 3 hour average to make it, right? Was there any startup and shutdown requirements that I have to include or exclude, or other process type tasks that are going on that might require you to look at it differently? Is it an average? Is it a total, right? Is it a rolling? Is it a block? And this gets more and more complicated. And again, many systems don't. And this is a big one too, looking at, is it operating time or clock time? If you have intermittent operation, you only want to use the hours of operation, you need to understand that part of it well, so you're using the correct data to roll into that compliance average. And again, these things are complicated, and then you've got the level of percent validity that you have to comply with in terms of understanding how much of that is required by me to present a valid average, right? So that's a big deal there too. And then, of course, online criteria. I stole this slide because me making something like this would take forever. This is neat. I'd like to see the automations. So, but anyway, so that's the idea behind the complications. Just a few examples of some of the complications. Again, the systems are designed for different purposes. And I hadn't talked too much about Excel, but I mean, Excel is a great presentation and data and analysis tool, but it's not a database. It's never really designed to be a database. And in many cases, the native calculations Excel puts together won't always meet the EPA requirements in terms of how things should be averaged up and totaled and so on and so forth. So, again, great tool, put data in it for visual purpose and review, but is it really you want it to be your compliance engine and your database for all of your data points that we just talked about? In the end, if you put together a plant system and a plan for the whole plant, they all integrate together well, and they should. They can provide information between different systems. You've got information coming from analyzers and plant control systems, the plant historian, and then even maybe passing along data to the EMIS after it's been validated, confirmed, compliant, and pass along those information values on a high level to the EMIS system in the end. Letting the validation and the day-to-day activities stick with the DAS side of things. So there's another example. We'll move on. And the last presentation Eric and them was talking about a few minutes ago, having a copy of those algorithms that are being used to reduce this data down to something reportable. And you have to have that documented, right? And so, DAS can do this in real time. It's an option to be able to flag that. It's not an absolute end all. You can't just turn it on and walk away and never look at it again. But it does provide that percent of time to help you look through things and a way to document how things are being taken and what approach are you taking to come up with these different calculation methods, and including those in your QA/QC plans and documentations on how that's approached. But again, the DAS is designed to not be that black box, to show you how the calculations are being performed. And then, here's it goes on to give us some examples of the various conditions that could be considered invalid or downtime, and therefore you'd have to be able to keep track of these different activities when these things happen, instrument adjustments, vibration checks, the different mid and low level highs that we talked about with PS9 calculations, all of those things going on at the same time, and being able to flag them in real time, not just for one parameter, but all the different points you're trying to collect for all the sources at a facility, that adds up to be a lot of work real quick like. And then maybe you can do some of these activities, manually, but how do you then go back and apply those and pull out the values that are not needed for compliance and you can't use for compliance? So having an automated tool in the system goes a long way with that. And it's still a word from a very wise consultant, what can it withstand the scrutiny, right? And what is that scrutiny? Are you following the various compliance guidelines and rules? Are you using it to understand the difference between only having good data being rolled up into your calculations and be able to easily exclude the bad data? And again, to reemphasize, it's not just a number. There's other things you need to quantify with those values that you're recording, so you know what you can and can't do with that data, in terms of maintenance activities and the various different process control sites and conditions that are applied. In many cases, your permits vary based on what mode the system's running in or what's going on. So you need to be able to apply those different things. And so understanding all that can get very complicated. So I think it's important also to identify, where are some of these things going to be flagged? How soon do you realize that you had downtime on an instrument? Are you responding and correcting the system in a real-time fashion? Does it wait till you get to the Excel before you realize you had downtime periods, or whatever system it's feeding into? That may be well up beyond the time frame, and you have unnecessary downtime that you could have addressed in a more real-time fashion. We've had clients that in the refinery space have been able to reduce their callouts for emergencies because they have a process in which they look and monitor the drifts and the way instruments are moving, and so they're proactively adjusting instruments to avoid downtime because they're riding up against their percent monitor availability requirements. So being able to have a real-time system to flag and monitor when an instrument has a fault, that goes a long way as well. And not to say that this information, as we pointed out the previous diagram, that information couldn't be sent to a DCS or some other plant system to notify the appropriate people. Again, depending on your workflow processes and things from there, you may need to send this over to a DCS system that then notifies the control operator, so they call out the environmental people or a different technician to take care of that stuff. But if you don't have that information in real time and you're not able to identify it quickly and easily, then it could get missed or skipped over. The other part of it is who's responsible for then to do the different validations? Who's taking that control? Who's responsible for validating the data? Did it pass its requirements, whether that be daily, quarterly, initial certification, those types of things? Who handles that today? The DAS does a great job with that, right? It knows when to use the data, how to set it up, and it helps document and report what's going on from there. And again, we talk about the calculations and some of the simple examples we said. There are far more difficult ones out there. Who's responsible for that? Are there calculations maybe happening in multiple different places throughout the food chain? From the PLC all the way up to the Excel documents. Like we were talking this morning, someone said, yeah, I need to be able to show my auditor the equation in the Excel sheet. Okay, well, if that's in the Excel sheet, what about everything before that? Where did the data come from, and what's happened to it since it got to that point? How can you I mean, yeah, you can document each piece of it, separate documentation for each system, but wouldn't it be easier to have all that kind of compliance thing in one location? And so that to me is, again, the big difference. If you looking for the best integration, being able to insert the DAS in the flow of data, ensure that it captures everything so that things can be spun off to operations, the technicians, to be able to do that real time and simplified compliance. Because there's the day-to-day activities that the technicians complain the most about, having to deal with every day, dealing with the activities of maintaining equipment and the routines and stuff that have to do with that sort of thing. Can this help them be more supportive on a daily basis and be proactive with what's going on with the SIMs at that point? Yes, it can, if things are integrated correctly and everything's talking well with one another. I touched a little bit on this earlier, but again, when it comes to pulling in all the necessary data points and requirements for these calculations, they're coming from different systems. You maybe have different forms of communication method available, where that's analog signals, digital indicators, and that sort of thing, as well as Ethernet and serial Modbus communication coming in from different instruments. And in many cases, the deployments of these, you have a combination of all of these being used on a source by source basis. So having a way to have a communication hub to pull all that information in, it does provide that capability. So again, looking back at this picture, integrating all the pieces and having them perform their individual functions, I think will go a long way to help support the compliance efforts. Because, and this is just an example of an NHV, if you look at the different parts and pieces of the data and where it comes from and what has to be pulled in together to do the overall calculation, there's a lot involved here. And this is just one of those examples of the data pieces that we talked about at the beginning of the different data retention type records that have to be recorded. Now this is probably a more extreme case where it has a lot of different combinations, but customers have situations where they need to capture all of these pieces and parts. Oh, wait, you're done taking. Okay, you're good. All right. We'll be sharing, like I said, as I said, they will be sharing the slides and presentations out with you all later. So our typical finding is this is kind of the flow of things and the way things are working. You can tap into different places in this timeline here or in this flow, but depending on where you tap in and pull the information out, who then has the responsibility for maintaining everything before that point? If you pick up data on the very end, what systems are responsible for controlling the validations, the calculations, and so on and so forth, the earlier you can get that into it, the DAS should be able to perform all those data processing calculations, compliance calculations, have graphs and displays and dashboards, so you can have a magenta light that flashes up on the screen over here to alert the operators that there's something they need to pay attention to, or realize that, hey, I'm working with invalid data right now, or data that I shouldn't be using. There's a lot of different things that can be thrown up in real time from that standpoint, as well as running through the various calibration or validation checks that are required every day and just doing those automatically, providing the reports and the alarms. And Eric touched a little bit on this as well. I want to emphasize the alarms because I do think that properly placed alarms and well communicated alarm sets can go a long way to helping the people responsible for maintaining the equipment, monitoring, operating the plant. You don't need to send every alarm to everybody. You get the cry wolf, I think, that's going on, right? So identify where the alarm needs to go. In some cases, maybe it's an email. Some cases, maybe it goes to a DCS system because that's how they operate. But identifying the different groups that are responsible for the tasks that need to happen when something is flagged or something is marked as a fault or so on and so forth. So we go back to understanding how that DAS fits into the pieces. And I keep throwing this up here because hopefully after repetition, people understand what I'm talking about. But the important part of this is to be able to see how it integrates and works with the existing systems in the plant. And if you spend the time to figure that out in the details in your planning process, you'll go a long way to making sure that the implementation is successful and provides the most value to not only environmental and reporting, but also the day-to-day operations. So I've got a little bit of a fun clip here to share with you because I did this clip when I first did a presentation back a while ago, so I apologize if any of you have seen these before. I hope it works. Any Formula One fans? No? Okay. 1950. Oh, no sound. Oh, that's no fun. You've got the announcer in the background going on, and he's saying that, yeah, he's trying to change one tire. And you got this crew. And then what happens is we fast forward a little bit because that whole series of pit stop takes a while. And so then they finish with getting the tire on, the guy ends up wiping the windshield, and off the guy goes, right? So this is 1950. There he goes, wiping the windshield.
Is it a one tire or two tire?
I think they just did a one tire change there, as I remember. So that was, and if you look at it, it was 67 seconds. That's how long that pit stop took, right? Here you go. This will show you. This is something I thought was very intriguing. So this is, modern day pit crews now, right? The car comes flying in. You've got all these people. They change it, they get it done, and the car is gone in 3 seconds, roughly 3 seconds, right?
Other than brake failures, that's typically how.
Right. So you are a bit of an F1 fan then. Okay. Oh, no. And I don't think I'd want to be on site because the sounds are just so strong and intense. It's exciting for someone. I get it. The point that I was trying to make is that, there's technology designed for compliance, and is it time to maybe use the best tools that are out there for the technology that's available? In the past, yes, I didn't just put DAS, I was promoting our system, but any DAS really, it has the technology to go out there and do things. So, look at the technology and see how they can benefit and what goes from there. So again, I hope you enjoyed the little video there and my presentation. I did not leave a question slide, so I will say, do you have any questions? Does that help those that are trying to figure out the difference? I mean, I could spend all afternoon talking about this, and we've done this before with clients, how it works, pros, cons, and the answer is, you want to sit down and think about how it affects your facility and how to implement it, because it's going to be different from site to site. Even if you have multiple facilities, they're going to have unique requirements and differences. You want to approach it as a standard way, but you need to look at each facility differently and making sure that you're addressing their concerns and their differences with a common approach. So, yes, go ahead. Yeah, absolutely. So that is another very good point, that the DAS has the tools to be able to go back. If for some reason the in real-time systems didn't catch everything and you realize a fault or a failure, something you got to go back and do. Yeah, absolutely. You go back in time and you find the periods and you mark it as invalid, save, and then everything gets recalculated based on those changes. It's got a lot of different QA features to do that kind of thing, because yeah, inevitably those situations do happen. Instruments fail, and these things happen, and so if you don't catch it, but before you submit it, you need to make sure that you reviewed everything and you caught everything so that you get it turned in. So yeah, there are ways to go back in and have the tools to flag things and look from there. There's also ways to throw up suspects and say, what, this is kind of outside of a window of normal operation here, and that's a good thing for operations. If things are starting to drift up or too low, and you're like, well, wait a minute, what's going on? You can dig into it a little further and say, oh, well, we're having trouble downstream someplace else with a different equipment, and it's affecting this. And so being able to look at those kind of trends and setting bands, right, where normal operation falls and getting flags. To me, that's the big advantage of the day-to-day operations. You can put that in there. Not to mention, you have flat lines or instruments that just stop reporting or continue to report the same value over and over again. You can put flatline adjustments on there to say, oh, okay, I'm expecting a certain amount of variation over this period of time. If I don't see that, let's raise a flag and make sure the instrument or something's not failing. So again, to help to be more proactive in those kinds of things and get ahead of that downtime the best you can. Great question. Yeah.
What's actually marked like on your exam? How did that information?
There are a lot of different ways to do this. I don't have pictures of it today. We have the ability to say, go into, and there's like a PLC device or a data controller that's tied directly in with the equipment. And so it operates independently of the application. So it can record and provide values and do calculations, and it marks them based on the status of passing or failing a daily check. Or if there's a fault line coming in from the instrument, it can start flagging the data as that fault line is, the digital is closed. The other option would be to pull values in from an historian and bring those values in to, but then you're relying on not just the number from the historian, but the conditions and statuses of each of those minutes that are coming in to the DAS so that you can build that same view that we were looking at. So you can pass along status and indicators from pi tags and different things that would then line up with the data, and the system can handle it that way for the most part. So it just kind of depends. But again, something else in the field or some other piece of equipment then has to do that validation, whether it's a PLC or the DCS or something is monitoring, looking at that data, and then passing along that information so that it could then be rolled up and the calculations can be performed as needed. It just depends on what infrastructures are available in that plant and who wants that responsibility. Does the DCS programmer, does the PLC guy there out on site want that responsibility for programming that logic in, or do you want the DAS to handle all of it? And I could say we have clients that use it in all the different ways from here to there. So, right, having some point of collection at the rawest value is our recommendation, because then you have full chain of custody of the data. You get it its raw, its form. You can do stuff to it to build into, you know, the other calculations. But if you've got that one raw point, you can then split it off and say, I need to calculate it this way for this part 60 rule. I need to calculate this way for JA. I need to calculate this way for RSR, so on and so forth. If I don't get the point till this end, something else has to document what happened to those values from that point to there. And is units of measure being changed, values, stuff can happen through that process. It just complicates the calculation. But again, not everyone is on board with the full system, and that's fine. We've adapted to tried to adapt to what people have asked for over the years. You asked me 6 years ago, and I said, nope, controller. You put that controller in, that's the only way to do it. Well, that doesn't work for all industries and all compliance needs. So yeah. Does that answer what you were?
Yeah.
Go back to that piece. The mouse is okay. Yeah, I have one that shows, well, it's right there. I mean, that's a marketing view of the controller. They prettied it up, but we have one upstairs in room 614. There's also one at the booth. You can get a better, closer look at it in terms of what it is. But I mean, it's basically a PLC with IO modules in the box, 19-inch rack mount device that has analogs, digitals, serial Modbus communication, Ethernet Modbus communication. And so this is the 4th generation of that box. There was an 8800, 8816, 8832. I think we're done at 8864 because the next logical step would have to go out of 4 digits. Again, I've accepted 4 digits now. I'm okay with the 4 letters. I don't think we could go beyond the 4 letters, though. We have to stick to that. Yeah, and that just messes up all kinds of, documentation of marketing. So no, there'll be maybe a Gen 2 or something like that. Just go that way. So, but if you want to see more of that, like I said, they've got some out at the booth that we have outside, which I guess is supposed to be available after lunch, but they're probably already set up right now. And then we've also got room 614 up on the 6th floor, where we've got a stack region system and some clients running a Flare-like config that kind of shows how the system works. So if you want to go up and there's somebody up there that knows more about it than I do. And if you have any further questions, that we can also have Alexis help, because that's why she's in here as well, being our subject matter expert on that concept. I mean, all 4 and the group that were here before us also know a little bit about it as well. So feel free to ask them questions and get honest opinions. Right, Eric? You said you had